Hi guys, it's Mrs. Milson, the last video. Okay, here we are. We're going to go over the Check Your Understanding on page 63, which is calculating standard deviation. And again, we're going to do it by hand, but when we get into school in August, I'm going to show you how to do this stuff on the calculator. Okay, but it's good to understand where the numbers are coming from. Okay, so far we have learned in this chapter how to describe a distribution using SOCs. So our shape, we're going to talk about the modes, unimodal or multimodal, whether it's symmetrical or skewed. Our outliers, which we just learned, are 1.5 our IQR rule, 1.5 of our IQR rule in the last section. Center is either mean or median, and we know how to calculate those. And spread, we started with range, and we learned how to calculate interquartile range in the last section. So now we're going to do standard deviation. Okay, standard deviation is basically the typical distance that each observation is from the mean. Okay, so it's kind of like the average distance that each observation or each data point is from the mean. Okay, so we're going to take this small data set. The heights in inches of the 5 starters on a basketball team are 67, 72, those numbers. Okay, so let's find the mean. So obviously for the mean, because the mean, which is our symbol right here, which we learned in the last section, is the sum of all my data points divided by the sample size. Our sample size here is 5, right? There's 5 starters. So to calculate my mean, I'm going to write this one out since it's not that many data points, not many observations. So 67 plus 72 plus 76 plus 76 plus 84 divided by 5. Throw that in the calculator. Okay, can you see the calculator?
Mm-hmm.
I'll put it right next to it. 67 plus 72 plus 76 84 divided by 5. I'm going to do my decimal. So, it's 75. So 75 what? 75 inches. Okay, so that's the average height of the starters on the basketball team. Okay, there's my work, there's my answer, there's my label, I'm good to go. Okay, so number 2, these are the steps for finding the standard deviation. Let's make a table that shows for each value. Okay, so my observations are all my x values, so that would be 67, 72, 76, 76, and 84. Then the deviation from the mean, so that's going to be each observation minus the mean. Okay, so I have 67 minus 75, 72 minus 75, 76 minus 75 twice. I'm going to move this up a little bit. And 84 minus 75. Okay, no, those are 1. What is that? Negative 3. That's an equal sign.
What is 9?
What is that? This is negative 8, right? And that's 9. Okay, so these are the deviations from the mean. And the thing is, if you add these up, so 9, 10, 11 minus 11, this is 0. Okay, so the total of your deviations from the mean should be 0. And then the last column is the squared deviation. So now I just have to square the deviations. So I'm going to take the deviations we just calculated and square them. So negative 8 squared. Let's see, what is that? 64, 9. 1 squared is 1, and 9 squared is 81. Okay, and we will sum those up. Let's see, 64 plus 9, and that is 156. Okay, so these are our steps. So I think that's it for number 2. We found observations, deviations from the mean, and the squared deviations from the mean. Okay. Show how to calculate the variance and standard deviation. Okay, stay down here. Okay, so we're going to do standard deviation first. Now, standard deviation is the symbol S sub x. Okay, so you'll hear me say S of x. Okay, it is equal to the square root of the sum of all the deviations. Oops, that's a minus. Squared divided by the sample size minus 1. It looks really scary, but it's really not that bad. So if we do this, let me do it over here. Square root. What's the sum of all of the differences of all the squares of our deviations? It's right there. It's 156. So we did all these. We took all the differences. Then we squared them. And then we added them all up. So it's 156 over, what was my sample size? My sample size was 5. So 5 minus 1 is 4, right? Okay. I guess I'll do it right here. So let's get what that is. 156 divided by 4 is 39. Square root of 39 is 6 point, rounding properly to 2 decimal places, 6.24. And again, what are we talking about here? We're talking about inches for height. Okay? So that's my standard deviation, which means each of these observations are typically about 6.24 inches away from the mean of 75 inches. Okay? Just kind of gives you an idea of how tight or how spread out your data is. Okay, variance is simply the standard deviation squared. Well, we've already got that. The standard deviation squared is just the 39. Okay, so that's the 39 inches. Now, standard deviation is what we use a lot. We're going to use standard deviation when we describe stuff, and we'll talk about it a lot more. Variance is going to show up about 2 or 3 times when we have to work with standard deviation, when we have to combine it and do some other stuff with it. So keep that in the back of your mind, that variance is just standard deviation squared, okay? So this will come up later on when we're doing calculations based on standard deviation. Standard deviation is the important thing, okay? So I'm going to squish in number 4 here. Number 4 says to interpret the standard deviation in this setting. Interpretation is key to statistics. So we have to describe basically what does that mean, okay? Well, we kind of talked about it. It actually means that the basketball starters' heights typically vary by about 6.24 inches from the mean height of 75 inches, okay? So that's an interpretation. I'll write it out. Oops, 75 inches. I really should write with pencils. Okay, so again, standard deviation is another way to quantify spread. We've already talked about range and interquartile range, but standard deviation is used with mean, which is used for primarily symmetrical distributions, okay? And what the standard deviation, again, it describes the typical distance that each observation is from the mean of the observations, okay? And we do an interpretation as the basketball starters' heights typically vary by about 6.24 inches from the mean height of 75 inches. Okay, so that's it. When we get back to school in a couple weeks, or a couple months, depending on when you're viewing this, we're going to kind of review the whole chapter, and I'm going to tie up some loose ends, and we'll have a chapter test.